This is the back of the page of our coordinate plane review. In number 6, we're going to find point T on the line segment CD that partitions it into a 2-to-1 ratio. So our ratio A to B is 2-to-1, and we'll use the partitioning formula, which is B times x1 plus A times x2 over B plus A. That gives us the x-coordinate of the point that we're looking for. And then B times y1 plus A times y2 over B plus A. So we do want to make sure that we put the ordered pairs in the correct order. Normally it'll say a line segment from C to D or from D to C. So you need to make sure that you note which is the first point and which is the second. In this case, it doesn't specifically tell us, and so we're going to use this as our first ordered pair and this as our second ordered pair and substitute them in that order. Order does matter because if you wanted in the 2-to-1 ratio, you've got a total of 3 parts on your line segment. If you wanted the longer 2 pieces to be closer to C, as it will be in this situation, versus closer to D, it matters which end you start from. So we're going to substitute our ordered pairs and A and B into our formula. So that will be 1 times x1, which is -4, plus 2 times x2, which is 2, all over 1 plus 2. That'll give us our x-coordinate of the point that we're looking for. The denominator of the other one will also be 1 plus 2. And then 1 times y1 plus 2 times y2. And that'll give us our y-coordinate. So then 1 times -4 is -4, and 2 times 2 is also 4. -4 plus 4 is 0. So that gives us 0 over 3 for our first coordinate. And then here 1 times -6 and 2 times 3, that also gives us 0 over 3. And so the point that we've found is 0, 0, and that is point T. Next, we're looking for the intersection of a circle and a line, and we're going to solve this algebraically as opposed to graphically. If we graphed the two and found the point where they intersected, it should give us the same result. But we're going to solve this one algebraically. The first thing I'm going to do is use my linear equation and isolate one of the variables. So I'm going to write down x minus y equals 2, and if I add y to the other side of the equation, all of the terms will be positive. I especially want to solve, it's convenient if I can solve so that my leading coefficient is positive on the side where I solve. So I'm going to add y, and this gives me x equals y plus 2. The next step is to substitute this expression, this y plus 2 expression, into the other equation that was given in the place of x. So this is an equivalent expression for x, and so I can replace x in the other equation with it. So that's what I'm going to do now. So I'll have y plus 2 quantity squared plus y squared equals 100. Now I've got to expand out y plus 2 quantity squared. It is not just y squared plus 4. We have to actually write it out and use FOIL or double distributing in order to expand that expression. And then we'll bring down our y squared and our 100. So I'm going to multiply this out. That gives me y squared plus 2y plus another 2y plus 4. And then I'll combine these like terms here, so y squared plus 4y plus 4. So I'm going to bring down these other terms, and I see I've got a y squared here and a y squared here. That's 2y squared plus 4y plus 4 equals 100. I really want to make the right-hand side of this equation equals 0 because I want to try to solve this by factoring, which if we have nice answers in the coordinate plane, usually it will be easily factorable. So I'm going to subtract 100 to the other side of this equation. And that is going to give me 2y squared plus 4y minus 96 equals 0. Now the next thing I want to do is start factoring, and I can see that these all have a common factor of 2. So before I even factor, I'm just going to divide everything by 2. That'll make it a lot simpler to factor, and that gives me y squared plus 2y minus 48 equals 0. So now I'm going to break this down, or unfoil it basically. I know my front of each binomial is going to have a y in it. I'm looking for two factors of negative 48 that add up to positive 2. And that is negative 6 and positive 8. After that, I'm going to set each factor equal to 0 to solve. Y minus 6 equals 0. I would add 6, and that would give me y equals 6. For one of the points, I'm going to have a y coordinate of 6. And then for y plus 8 equals 0, I'm going to subtract 8, and I'll get y equals negative 8. So that'll be the y coordinate of my second point. So now I'm ready to find the x coordinates that go with those. So I'm going to substitute each of these into my equation where I isolated x over here and find the x coordinate that goes with each of these y values. So first I'm going to substitute for y equals 6. So x equals 6 plus 2, which is 8. So my x-coordinate is 8, and my y-coordinate is 6. And that is one of the points where the two graphs, the graph of the circle and the graph of the line, would intersect. Then I'll substitute my other y-coordinate. So x equals negative 8 plus 2, which is negative 6. So my x-coordinate is negative 6, and my y-coordinate is negative 8. And that is the other point where these two graphs would intersect. For number 8, we're going to rewrite this circle equation into standard form. And so for standard form, that's where we have our quantities squared, and it shows us the h and k and r squared. So we want it to look like x minus h quantity squared plus y minus k quantity squared equals r squared. In order to make this happen, we have to create perfect square trinomials for both the x grouping of terms and the y grouping of terms, and so we'll have to complete the square. And I like to say half it, drop it, square it, add it. So here we go. We want to group together our x terms, so x squared and x squared minus 6x, and then we're going to leave a space to add a perfect square to create a perfect square trinomial. Then we'll put our y terms together, y squared minus 2y, and we'll also leave a space to complete the square here. And then we're going to subtract 1 to the other side of the equation, and then we're going to leave the same spaces to add those same perfect squares to the other side, because anything we add to the left-hand side of the equation, we also have to add to the right. Now we're ready to complete the square, and that's when we do this. So we'll look at the b term. We'll take half of that term and drop it into parentheses, so that's going to be x minus 3. Square it and add 3 squared to both sides. So 3 squared is 9. There we go. Then we'll do the same thing for the y's. We'll look at the b term. We'll take half of it, so half it, drop it into the parentheses, so y minus 1, square it, and add it to both sides. 1 squared is 1. This side is in the right format. We've got our quantities squared, and on this side we'll combine like terms to get positive 9. So the center of our circle would be 3, 1, and the radius would be 3. And here's the equation in standard form. Number 9, we're working in the reverse. We're going backwards to general form. So we'll have to take each of these quantities and square them out, and then we will order the terms into the correct order. So we'll start with x minus 2 times x minus 2. And then we'll have to do the same thing for y plus 3 and y plus 3. So we'll go ahead and multiply these. This is going to give me x squared minus 2x minus another 2x plus 4. So that gives me x squared minus 4x plus 4. Then over here we'll do the same. Y squared plus 3y plus another 3y and plus 9. So that gives me y squared plus 6y plus 9. Now we're going to start ordering the terms in the correct order. So in general form, they go in alphabetical order, x, then y, and then higher powers to lower powers as well. So the first term I'll start with is x squared. And then I'll go to y squared. And then we'll go to negative 4x. And then we'll go to positive 6y. We'll combine the 4 and the 9 and bring down our 16. Then the last step is to make the equation equal 0, and in order to do that, we'll subtract 16, and that will give us x squared plus y squared minus 4x plus 6y minus 3 equals 0. Last one. Circle C has a center of 5, 2, so that's our H and our K, and a radius of 6. Does the point 8, 7 lie on circle C? What we'll do is write the equation for circle C, which will be x minus 5 quantity squared plus y minus 2 quantity squared equals r squared, which is 36. And then we will substitute this for x and y, the ordered pair 8, 7 for x and y into the equation, and we'll see if it truly makes a statement of equality that the left-hand side equals 36. If it's equal, then the point lies on the line, and if it's not equal, then it doesn't. All right, so here we go. We'll have 8 minus 5 quantity squared plus 7 minus 2 quantity squared equals 36. Or does it? We don't know yet. So we will simplify this. 8 minus 5 is 3. And 7 minus 2 is 5. And we're going to go ahead and just simplify the left and see if it comes out to equal the right. 3 squared is 9. 5 squared is 25. 9 plus 25 is 34. So that does not equal 36, and therefore the point 8, 7 does not lie on the line, or on the circle, excuse me. That's it for this review. There's another review linked to my blog with the answers if you feel like you need some more practice or a little bit more guidance before the quiz tomorrow. And I know Mr. Harmon will also be sharing some things with you as well. Good luck. Reach out to us if you need help.